Now, when you're working with the formula for finance, right, one of the things you need to take note of is that this is applied when you're dealing with sinking funds, right? When you're dealing with sinking funds, when you're dealing with savings or retirement funds, right? So remember, this is the money that is paid regularly into an account, and it's equal payments, right? So this formula, if you can remember from our previous sessions, we said this formula is it assumes that the last payment does not earn interest. It does assume that the last payment doesn't grow interest, right? So we are just gonna apply that formula on a number of questions, right, that we will be looking at and see how we deal with it, right? Here's the first question. So suppose that 1,000 rands is deposited into a bank account, right? Now 1 month later, a further 1,000 rand is deposited into that account, and then a further 1,000 1 month after this. If the interest is 6% per annum compounded monthly, how much will have been saved after 2 months? Right. Now, listen carefully to this question. I'm gonna make a nice timeline of what's going on there. Right. Now, what is the question saying? If I put T0 here, let's just say also put T1, T2, T3, and perhaps T4. Okay. So we have 1,000 rands which is deposited here, okay, into a bank account. Then 1 month later, you deposit again a further 1,000. So let me just be putting 1,000 then even here put the 1,000, right? And then a further 1,000 1 month after this. 1 month after this. Now, if the interest is 6% per annum compounded monthly, 6% per annum compounded monthly, how much will have been saved after 2 months? So the interest during this whole period, the interest was how much? It was 0.06 divided by 12. Okay, now they're saying how much money saved after 2 months. How much money will have been saved after 2 months? Now I don't know, should I tell you first? Should I give it a try? Okay, let's work on it. First of all, when it is saying how much money will have been saved after the 2 months, I need you to understand that it's these 2 months here. You understand? Because if you follow the question carefully, it says 1,000 was deposited into a bank account. Then 1 month later, 1,000 is deposited again. And then another month later, 1,000 is deposited. So when they are saying how much money will have been saved after these 2 months, they are talking about these ones. These are the 2 months there. It's quite important to understand that, ne? So it's just how the wording of the question was. I know it's not the best of the wording, but I think this comes from a mind action textbook. And their English there sometimes, it's somehow. But understand that when they're saying after 2 months, they mean after this month and that month. Okay, so we're gonna do this in 2 ways. The first method is just an understanding of compound interest and how money grows if it is subjected to compound interest. Now allow me to then quickly do this. Quickly take this here, and then we do understand that this is the 2 months. It's also here. Now how do we solve this? The first thing is that we can say this money that was deposited here, it's gonna stay for 3 months. Do you see that? from here to there, it is 3 months. So this 1,000 is gonna stay in the bank for 3 months. What about this one? This one is gonna stay in the bank for 2 months. What about this one? This one is gonna stay in the bank for 0 months. Okay? For 0 months. It stays in the bank for 0 months because we want to know how much is saved after these 2 months again. But this money is not allowed to grow because it's more of like saying after the 2 months I want to see how much I have. So you have to understand that you just deposited the 1,000 and already you want to check your balance. I always say this, that this usually relates to us as black people, that it could be anyone, in fact, like in most cases people are just impatient. They want to know, hey, how much do I have in my account, man? You see. So even here is the case. You start with 1,000, a month later you deposit 1,000, and then after a month later you also deposit 1,000. But immediately after depositing you say, I want to check my balance. I want to know what is my balance. You have not even gone anywhere. It's just 2 months. It's just been 2 months, but you already want to check your balance. So now, as we are here to then calculate and see how much will be your balance. So the first method, like I said, is to understand that we're going to be using the formula A is equals to P1 plus I to the power N, which is just the compound interest formula. Okay, so our principal amount, we're gonna do this backwards. I'm gonna start with the 1,000. The 1,000, it stays in the bank for how long? Or even is fine. Let's start here. This 1,000 stays in the bank for how long? That 1,000 there, the interest is 0.06 over 12. It stays in the bank for 2 months, which is the first month here and then the second one there. So it stays for 2 months. It doesn't stay for 3. You have to understand that it doesn't stay here for 3. It stays, you deposit it here, then this is the full month that was completed while it is inside, and then the full month that was completed while it was still in the bank. That's why we want to know how much have you saved in those 2 months. Okay, so it stays there for 2 months, and then this one, it stays for how long? This is its full month, so that one stays for 1 month only, which is 1 plus 0.06 over 12, and then it stays for 1 month. What about this one? 0 months, because at that day when you just deposited it, that's when you want to know the balance. It would have stayed for a month if we're calculating our balance after 3 months from the initial deposit. You see, so this one only stays for 0 months. So you say 1,000 into 1 plus 0.06 over 12 to the power of 0. The 0 here tells us that it stays for 0 months. So what is the answer that we get? So indeed we get 30, so that's like 3015 comma what, comma 03. Okay, so that's how much you will have saved after that 2 months. 2 months meaning 2 months after the initial deposit. Hope that is clear. Hope you are able to find the same answer as me. Now, this very same question, we're gonna do it using the future value formula, because the future value formula here applies since our last value did not earn interest, so the future value is going to apply, right? So how do we apply it there? Let's understand that the money that you are depositing equally there, that's gonna be your X. And then we are looking for future value. The interest is given, and then the number of payments that we made there, how many payments did they do. So let me write the formula here, and then we can follow along as we do the question. So for future value, we say future value is equals to x into 1 plus I to the power of n minus 1 all divided by I. Now now here was the question, so that we can also be looking at it. Oh, now it's too small. Yeah, right. So let's understand, guys, that this part here is our x, and then the interest is given, and then we need to know how much will be saved after 2 months. However, in this formula, what is n? What is n? Let's understand that n is not number of years. However, n is the number of payments. Okay, it's the number of deposits or payments. Number of deposits or payments. Now, how many deposits were made there, guys? If you remember our timeline, look at T0, T1, T2, T3. They said this guy, he initially deposited 1,000, or this guy or girl, we don't know who it is. 1 month later, and another 1,000. 1 month later, another 1,000. Then it was done. So how many deposits were made, guys, or how many payments were made? It's 3. It's 3 payments. The thing is that most people, they make a mistake of associating this n with number of years, which is not necessarily true. Another thing is that they take the number of this that was asked in the question, right? You see here, they wanted to know how much it will be saved after 2 months. Then someone just says, n is 2. It doesn't work like that, okay? You have to count or calculate your number of payments. So therefore, the future value here will be 1,000 into 1 plus the interest, which is 0.06 over 12 to the power of 3 minus 1. Then you divide by your interest, 0.06 over 12. So how much do you get there? If you put that in your calculator, say 1,000, and then 1 plus 0.06 over 12, right, to the power of 3 minus 1, all divided by that 0.06 over 12. How much did you get, guys, before I tell you my own answer? So we still get 3,015,03, which is the same as what we got previously. Okay, so that's why you can understand that this formula, it makes life easy because it's just one formula, right? But then here, if you do it this way, it's manually. You're doing it manually, the longer way. Okay, and now understand that the thing is, why do we need to use the formula if we can do it manually? You can have a lot of payments, 90 payments. How are you going to do that manually? You see, that's why usually a formula is going to assist us. But for these ones, it's not a lot of payments, so we can just be using manually also. But also, if there are a lot, just use the formula. Let's look at the next question. Suppose that 1,500 is invested every month, starting immediately for a period of 12 months. You are given the interest and then the future value of the investment after 12 months. We need, what is the future value? Sorry, the question there is actually calculate the future value of the investment, calculate the future value of the investment. Suppose that 1,500 is invested every month, starting immediately for a period of 12 months. Starting immediately for a period of 12 months, you are given the interest. Calculate the future value of the investment. I want to give you a chance to do this also. Try it and then we look at it. Now, this question, you need to understand it properly. Understanding it is going to come from timelines. If we can remember timelines, right? A timeline for 1 year. A timeline from 1 year starts from T0, right? Then it goes T1 or T2. Oh my goodness, I should be writing this at the bottom. Imagine at T0 or at T1, T2, T3, T4, 5, 12, right? So this is the timeline for a year. This is a timeline for 1 year. Now, please guys, I need you to understand that this timeline, you can either be reading it in terms of payments made at the end of the month or payments made at the beginning of the month. Okay, so this T0 here is the December of last year. If this timeline of ours is of 2025, this is month end December, like December 31st 2024. That will be T0, right? Or you can also think of T0 as the 1st of January 2025. 1st of January 2025. Then if you decide to work with month end, this T1 will be the month end of January. Okay. What is much better here, what is much better is to do this way so that it doesn't become too much long. At the top here, I'm saying month end. Okay, so month end of December last year, month end of January this year, month end of February this year, month end of March this year, all the way to March, April, month end of April this year. So this is 25. Let me just be saying 25 so that we understand that it's 2025. This is 2024. And then month end April, what comes? May, then June, July, month end of July 2025, August, September, October, November, December. So here it is the month end of December this year. Okay, good. Now here, this side here, we are looking at beginning of the month. Beginning. I wrote begging. Guys, how would we write beginning, mar? Yeah. If I get it wrong, just know, guys, I'm not the first to get this wrong. The spelling really chows a lot of people, even our politicians. Right. T0, it's going to be the beginning of January 2025. Like if you are going to look at this timeline in terms of the beginning of the month, this will be beginning of January 2025, beginning of February 2025, beginning of March 2025, beginning of April 2025, May, June 2025, July, August, September, October, November, December 2025, and then this is gonna be the beginning of January 2026. Okay, this is how we read our timeline. You are either going to be going from December to December, or you're gonna be going from January to January. But understand, if you use January, you're gonna start with January of this year and end with January of the next year. If you use December, it's gonna start with December of last year, and then you're gonna end with December of this year. Now let's understand, what did they say about this person. We're told that this person, decided to invest the 1,500 every month. Ne? When they say every month, we don't know whether the person decided to do it at the beginning of each month or at the end of each month. Ne? But here is a problem. If you decide to work with, to say that this guy, he started at the beginning of each month, it's fine. It means he starts in January, he goes February, March, April, May, June, July, August, September, October, November, December. Ne, December. It's okay if you move, if you decide to do it that way, to say he started from January all the way to December, and he made 12, he was paying for the period of 12 months, you will be okay. You will be fine. Okay, you will be fine. But the thing is that, you know what is going to be the problem if you end here? The thing is that when you are working with future value payments, the last payment should not earn any interest. So if you end here, what is going to happen to the payment you make on that December? Do you see that it's going to earn an interest for a month? So that means it would be wrong to end there. You would need to go until there. But now it wouldn't really, so it would make sense in that way. Then if you decide to say, no, this guy heard about this deal in December, then he started to pay from January to December this year, that's also okay. You see, that's when now the word immediately, that was the key word there, immediately. When they're saying immediately, you must know that we're not talking about just 12 payments in a year, but the payments will be 13 payments, because it will be this one, starting, he will be starting here all the way to there. So how many payments will be made? There will be 13 payments, and the last payment will not earn any interest. You see, so how do we use the future value formula? We say F is equals to X. Guys, please write this formula down, because some of you did not write the correct formula there. Please write the formula down. Here it is. Ne? So X is the amount that is being paid every month. There is 1,500. And then we say 1 plus, what was the interest? Is 0.18. You divide it by 12 to the power of what? Now, how many payments were made? Is it 12? No, it's 13, because it started immediately. So it's gonna be 13, and then like that, all divided by 0.18 over 12. So I'm straight away using the formula, because the longer method, it's gonna take us time. So the answer that we should get, I think I saw that answer somewhere there. Mr. Fatai says what? 21,355, is it 24? Hey man, your handwriting, man. But it's fine, I can see. Alright, that is the correct answer, guys. So here's the next one, guys. Okay, so Tabiso starts in saving money in that unit trust fund, immediately deposits that 800 into the fund. Thereafter, at the end of each month, he's depositing 800 and continues to do this for 10 years. Calculate the future value of his investment. Give it a try, and then we look at the corrections. So understanding of this question is quite crucial. We do know that we will use our formula. X future value is equals to X into 1 plus I to the power of n minus 1. Right? Please, guys, how many brackets do we have? 1, 2, 3, 4. They make a difference, those brackets. So you must have them like that. Now, this person is Thomas is investing or depositing 800 equal 800 rands, right, as the equal payment. Now, the interest is given as 0.08 over 12, right, to the power of now. And how many payments? Guys, future value is not difficult. The only thing that people cry about in future value is the number of payments. That's it. You can substitute everything correctly and get number of payments wrong. The whole question is wrong. So that's how sad it is. So you must make sure that you understand the number of payments. You understand? So we were told that he did what? He immediately, good people, what did he do? He immediately deposited 800. If you immediately deposit, that means your timeline will be looking like this. You immediately deposited, right? And then you continue to do that for 12 months. So that means in 1 year, in the first year, you're going to have 13 payments. Then thereafter, right, because they talked about 10 years, right? In the first year, how many payments are you going to have? You're going to have 13 payments. In the first year, you're going to have 13 payments because you started immediately. But then the remaining 9 years, it's just going to be 9 multiplied by 12 to get the total number of months there are. So if you say 9 multiplied by 12, what is the answer that you get? So if we say 9 multiplied by 12, we get 108 payments in those remaining 9 years. So if you say 108 plus 13, guys, I believe you should get a total number of payments, total N to be 121 payments. Okay? Or another way you can think of it is that since they said 10 years, you simply say 10 multiplied by 12. That gives you 120 months, which means 120 payments. However, because you started immediately, you just add 1 to it. Okay? So therefore, you substitute there 121 minus 1 all over the interest, which is 0.08 over 12. Right? Now, I remember I saw a correct answer. Let's see. Miss Isabel, there is really something that went wrong there. Check it, mom. Alright, so the correct answer will be 148, 132,54. Very good. So guys, that is the answer there. You need to just to do more questions and understand number of payments. If you can understand that, you are done with future value. Patrick decided to start saving money for a period of 8 years. That's how the next question starts. For a period of 8 years. Starting, guys, I like this problem. Mamel, starting on the 31st of December 2009. Starting on the 31st of December 2009. Now, at the end of January 2010, 2009, 2010, in 1 month time, what does he do? He deposited an amount of 2,300 into the savings plan. He is doing this at the end of January 2010. Thereafter, he continued making these deposits of 2,300 at the end of each month. For what? For the planned 8-year period. The interest remains fixed at 10% per annum compounded monthly. How much will he have saved at the end of his 8-year plan, which started on the 31st of December 2009? Beautiful. Now, how do we do that? Right. Now, what I'm going to do, I'm going to grab my timeline again. But my timeline, obviously, I'm going to make it just like this. I know that I have T0 here, then I have T12. But remember, this is timeline for 2010. Understand that this is a timeline for 2010. It means when is T0? Is December 31st. When? 2009. Remember that on T1 here. When is T1? is January, ne? It's January 31st, right, 2010. I'm saying January 31st just to indicate that it is the month end of January 2010. And can remember, if you are looking at month end, we are at the top here. Then if you are looking at each as beginning of the month, you'll be looking, you can also do that. But this one, they said December, so we look at month end January, month end February, month end March. So this means here it will be month end of December 2010. This is just the first year. Understand that you always work with the first year, then the remaining years are gonna be okay. The remaining years, we just say those remaining years times 12. But for the first year, deal with it thoroughly. Please listen to what I'm saying. For the first year, deal with it thoroughly. Just write the timeline and understand how many payments were in the first year. Then you do the rest. So we're dealing with the first year now, 2010. So, when did the payment start? How much will he have said? He made his first deposit, ne? Month end January, meaning the first deposit was here. Was the first deposit here on December 31st? No, it was not there. Why? This is because that is when Patrick decided. Listen carefully. That's when Patrick decided to start saving money. Right? But if he started to save money from the 31st, right, one might ask, or rather, maybe let me hear from you guys. Do you think that here on December 31st, when you listen to the English here, do you think there was payment made on December 31st, or there was no payment? Payment only started in January 31st. Guys, please, please type for me there whether you think there is payment on 31st or no payment. All right. What did Miss Nobile say? Now, good people, the answer is that there was no payment made. The answer is that there was no payment made. Why? Because when you decide to do something, unless they added the word immediately, he decided to then make the payment, you can't assume there was payment made, because they didn't tell you that immediately he paid. It is just when he decided to say, you know what, in his mind, I want to start saving money, then he started to save his money. Yes, the saving started on December 31st. That one I understand. It was New Year, ne? Then this guy was like, you know what, when I enter 2010, I want to save money now. No more alcohol, no more dates, no more what. It's just a thought. He decided it. And then he started to save money. Whatever he's working and getting in January, he's saving. Then he starts making his payment on January 31st. That's why they said at the end of January there, he deposited an amount of 2,300. And that's where we started to hear even the amount he was depositing. So that is it there, guys. It's literally like that. Okay, so the payment started on January 31st. Then he continued to do so until December. That means he's gonna make 12 payments. It's not gonna be 13. It will be 12 payments because he didn't start immediately. That is for the first year. How many years are remaining? 7 years. Now in 7 years, how many months do you have? You have 12. So you say 7 times 12, it's gonna be 84. Then when you add these 84 plus the 12, the total will be 96 payments. Okay, so the total would be 96 payments there. So when you substitute this into your future value formula, you would say f is equals to x 1 plus I to the power of n minus 1 all over I And then now the amount that is being deposited is 2,300. It's 2,300, and then the interest is 0.1 over 12, and then it's 96 payments all over 0.1 over 12. Okay, so what is the answer? So the answer is 336,216.47 rands. That's how much you will have saved there. Okay guys, I hope that was clear. We're gonna do at least maybe one more. I'm gonna show you just one more, two more on this future value before I introduce also just present value, just to understand the difference. Okay, now Dinah has just turned 20 years old and has a dream of saving 8 million rands. Dinah wants to save 8 million by the time she reaches the age of 50. Wow, that's beautiful. So she starts to pay equal monthly installments or monthly amounts into a retirement annuity, which pays 18% per annum compounded monthly. Her first payment starts on her 20th birthday and her last payment is made on her 50th birthday. How much will she pay each month? Yay! Yay! Yeah, good people. I want to give you this one, and I want to give you a chance to try this one out, right? It's quite a beautiful question. Now, well, actually, to understand this question, right? Everything else is gonna be fine. You can solve for x. I know you can solve for x, but the value of n is what is important here. Let's understand that they said Dinah, she just turned 20 years old. She has a dream of saving 8 million by the time she reaches 50. Ne? She starts to pay equal monthly amounts into a retirement annuity, which pays 18% per annum. Her first payment starts on her 20th birthday and last payment is made on her 50th birthday. Now, because the last payment is made on her 50th birthday, we know that last payment does not earn interest. It does not earn what? Interest, which is very much needed for our formula to work, for our future value formula to work. Ne? The last payment must have not earned interest, and indeed it didn't earn interest, because immediately she's turning 50, that's when she also makes her last payment. So we want to know the balance then after she does that. Now the number of payments. Future value, guys, is 8 million. We know we're looking for 8 million. That's what she wants in future. We don't know how much she must be depositing every month, but we do know that the interest was 0.18 over 12 to the power of what? All divided by 0.18 over 12. Now, good people, the exponent there, all you need to understand is the following. Let's take any of you guys' birthdays. Okay, my birthday is on the 23rd of February. Ne? It's on the 23rd of February. Every year, by the way. It doesn't skip. Now, this is 2025, right? This is 2025. Now, obviously, from 20 years to 50 years, that's 30 years from now, right? That's 30 years from now. So if we say 2025 plus 30, we are looking at what? 2025 plus 30, we are looking at 2055. Yo, my birthday in 2050. Will I still be there? So we are looking at the 23rd of February 2055. Remember, on this very same day, when I'm birthdaying, I make my last payment, which is not gonna earn interest. It's okay, and that's what the formula is based on. However, my first payment, I made it immediately on my birthday. If I listen carefully to the word, listen. Her first payment starts on her 20th birthday, which means her first payment started immediately on her 20th birthday. Listen, my first payment started immediately on the 23rd of February until 2025, until 23rd of February 2055. This shows you that there was an immediate payment that was made. The first payment was immediate. You see, there was no gap given. She didn't say if her birthday is on the 23rd, she will start paying in March. No, she started to pay on the same day. And we know once there is an immediate payment, it adds an extra payment. So we want to know in those 30 years, if you say 30 multiplied by 12, how many months do you have? 30 times 12, you get 360 months. However, because there is an immediate payment, you add that immediate payment, and therefore here you put 361. So the number of payments was 361. Very good, Mr. Fatai. Very good, Miss Isabel. And the rest who got it correct. Very good, guys. But if you didn't get it, I hope that you do understand why, though. It's just a matter of once there is like a sense of immediately you start to do something, then it adds an extra payment. You see, because you should be paying 1 month after. You see, if you pay 1 month after, then yes, the formula, you're not gonna add any extra payment. But if you do it immediately, you get an extra payment. Then guys, to solve for x there is quite simple. Just put this in your calculator without the x. Just put it in your calculator. Whatever answer you get, say 8 million divided by that answer, it's gonna be your x. So how much do we get? I think Mr. Fatai said x is 558,41. 558,41. So that is the amount of money she must be paying every month for 30 years. Okay guys, I hope that is clear, and it is with my hope that we do understand. Let me just summarize then. So please just know that for future value payments, these are easy. Just take care of the number of payments. Okay, just take care of the number of payments. Now for your number of payments, understand that if the payment was made immediately, that tells you that there is an extra payment. If the payment was made, if payment is made a month after someone decides to invest, then there is no extra payment. That is it. Okay, so you don't add any extra payment if someone made a month after, meaning that instead of starting to pay in December, maybe you start to pay month end January, then you go like that. Okay, or instead of paying at the 1st of January, you pay on the 1st of February, then you do it like that, then there won't be any extra payment. But if you do it on the very same day, then you're gonna have an extra payment. Now the application of this is going to be on sinking funds. Now good people, I just want you to quickly understand what are sinking funds, because these are then the questions that usually will be there in your exams. So what is a sinking fund? A sinking fund is this. Let's say you buy a laptop. Let's say you buy a laptop. Right. Here's your laptop there, a very nice laptop you want to use at your company. Now this Dell laptop cost, the current cost, the one you bought it with, meaning that is the current cost in the shop. Let's say you buy it at 4,500. Okay, you buy it at what? At 4,500. Two things are gonna be happening here. Okay, two things are gonna be happening. The first thing is that your current laptop, it's going to depreciate. It's going to depreciate. It's gonna lose value. I told you that assets, they lose value. So it's gonna depreciate. Let's just say you bought it in 2025. You bought it in 2025 at 4,500. It's gonna depreciate. Now in 2028, it's gonna have a different price. It would have depreciated, right? So your very same laptop, it will have depreciated. So now it's gonna be lesser value. You can use this formula here. A is equals to P into 1 minus I to the power of n to get how much it is in 2028. Or you can use this one, P into 1 minus IN. Remember, Gary, if it is reducing balance, you use that. If it's linear, you use that. Then you will get how much it costs in 2028. Let's just say it depreciates at 10% using compound decay. How much will it be in 2028? In 2028, you say 4,500 into 1 minus 0,1 to the power of 3, because it's 3 years only from 2025 to 2028. So how much does it cost now? How much is its value now? 4,500, 1 minus 0,1 to the power of 3. Now it's costing 3,280,5. Same as my phone here. I bought it in 2022. If I want to sell it right now in 2025, I have to calculate the rate at which it has depreciated with, and whether it was linear or reducing balance. Then I'm gonna get how much I must sell it by. Guys, you see this money here? This is how much the laptop is now worth. So this is the worth of the laptop in 3 years. The worth of the laptop in what? In 3 years. That's how much it cost. That's how much it's worth now. Because you were using it. Okay? It depreciates. You were using it. So it's gonna depreciate. I hope that we are clear there. The one you were using, the one you bought, it's gonna depreciate. Now, in the world, remember this one is the one that you're using. Let me do this so that we understand that this is the one that you are using. It is costing that. Now, right now, if you go to ShopRite and try to buy noodles, do you know that at some point those noodles that we are buying 40 rand, Maggi noodles, they are now 40 rands, guys. Those noodles were at some point 28 rand, 25 rands. Cool baked beans, at some point they were 8 rands. Go and check the price now. A taxi used to be just 5 rands. Go and check the prices now. Ne, a laptop used to be very, very cheap. Go and check the prices now. We used to buy bread with 10 cents. But that one, yeah, but that's what they say. You used to buy bread 10 cents. Look at the cost of bread now. Guys, what has happened? What do we call that? Yes, inflation. It's called inflation. So, this one, I carry it is at your office because I carry you are using it. The same laptop in the shop, let's say Dell shop. The same laptop at the Dell shop there. Ne? At the Dell shop, it is what? It is increasing in value due to inflation. The cost of that laptop is increasing. So there you use the formula A is equals to P 1 plus I to the power N to get the new cost in 2028 in the shop. So let's just say it was also 10%. So that means now the new cost will be how much? A will be 4,500 into 1 plus 0,1 to the power of 3. This is going to be the cost in the shop. Just remove the negative, you put the plus. It's now 5,989,5. This is the new cost at the shop. New cost at the shop. So things they do every year, guys, there is inflation. I know accounting students, you understand this, even economic students or business studies. Now, because there is inflation, guys, it doesn't mean that bread they're adding more slices or anything. It's just being expensive with the same number of slices. That is what is inflation. Okay, so companies, what they do is that they know that whatever machinery they are using, after a certain time it's going to depreciate. When they try to sell it, they will have to sell it at a lower price. Why do they sell the machine? Because usually they want to buy a new machine and they want to use this old one as a trade-in. So this is called a trade-in value. A trade-in value. I got an iPhone. This iPhone, when I sell it to someone, right, I'm able to upgrade to a bigger version, but I'm gonna have to top up. I can't just say, man, take my iPhone 13 and then you give me your iPhone 14. No, I give him the iPhone 13, then I give him some money also. So similarly, their machines, they sell them. That is called a trade-in value. Once they sell it, they will get 3.280. Now the thing is that after selling it, they still can't afford to buy a new machine. They can't afford to buy a new machine because a new machine will be costing way more due to inflation. So what they do is that they calculate the balance there. They say, okay, how much are we gonna need to top up? How much are we gonna need to top up the money we got from selling? Well, the top up amount is gonna be 5,989.5 minus 3,280.5. You see, now I'm not sure. Okay, 3,280.5, you get 2,709. This is how much they must top up. Good people, this amount they plan ahead. They plan while they're still in 2025 that we are going to save money on the side, and that money that we're saving, it's gonna be the 2,709, so that in 2028 we can afford to buy a new machine. This money they're gonna save aside, this is the one that is called a sinking fund. It's called a sinking fund. How are they gonna save it? They are going to be depositing money every month into an account, and that money, it must accumulate to a future value of 2,709. That is a sinking fund. So they have to ask themselves to say, so how much must we save monthly so that we'll have this money to top up? So they will use the formula F is equals to X 1 plus I to the power of N minus 1 all over I. The future value, the money that we want in future to top up, is 2,709. We don't know how much we must pay monthly, but we do know that the bank can give us an interest, let's just say, of 10%, because the interest they will give you. How many payments are we gonna make? Well, we're not gonna make any payment immediately, but we're gonna make payments in 3 years. So that is 12, 24, that is 36 payments. Okay, so we put 36 here, and then here, down there, we're gonna divide by 0.1 over 12. Good people, if you do this, you'll be able to solve for how much must be paid monthly into the sinking fund. The sinking fund is the amount of money we want to have in future, so that we can afford to top up and buy a new machine. Okay, so that is it. That is it there, guys. That is sinking funds. Okay, so when you do questions, number one, the question might go with you step by step. Calculate the value of the printer in 7 years, right? If we depreciate it like this, calculate the new value of the printer in 6 years due to the inflation. Usually the rate for depreciation will be the same as the rate for inflation, but it's not always like that. And then once you know how much it will cost in future, and then you know how much yours will be worth, the truck you're using or the machine or what, then you can calculate the money to top up. That money to top up is the sinking fund. That is your future value. Okay, it's your what? Your future value. Then you'll be able to solve for X. Okay, so guys, that is it about future value. And indeed, we do need to then talk about present value, as most questions they do come there. But guys, this should be enough for you to practice. I will send you questions, try to do them, not a lot though, so that we can practice them.